Hello everyone, my name is Shobi Abdi, and I'm a Principal Architecture Evangelist here on the Salesforce Architects team. And in today's video, we're going to talk about a topic that I know everyone's going to have fun with, throughput issues. Now that I've got you excited, and I've got your attention, you may be wondering, well, what are throughput issues? Now, in the most technical speak possible, and you can actually find this on the well-architected website, throughput are the number of concurrent calls that a system can make within a given time interval. Essentially, whenever you're calling a page in Salesforce, whether it's a lightning page, a list view page, a report, it's making calls to the database, it's making calls to the app layer, it's making calls across multiple systems and multiple layers in order to get you back a response. That is throughput. So we're not talking about throughput in the sense of like if it's taking too long or it's too short. It's more of like how long it's taking, period. Long may be good. Long, actually more often than not in this day and age, is bad. And especially with throughput issues, sometimes they're the hardest to detect. And even more often, sometimes they're even the hardest to resolve. In the simplest way, you may find a throughput issue and update a query or optimize a page. Sometimes the hardest ones involve an entire data re-architecture, where you need to completely redo your data model, your database, and everything in order to accommodate significant throughput issues. So why throughput? Well, we're going to be talking about throughput in the context of anti-patterns. And how do we resolve throughput anti-patterns that exist within an application? Specifically, an application we're going to look at today. We're going to look at an app that we've built. We're going to look at a code base. And we're going to see present throughput issues, and we're going to start to resolve them. Or at least resolve them as best we can. Throughput can sometimes be a little bit hairy that way. So I'm talking about patterns. I'm talking about anti-patterns. Where can I find all these amazing patterns and anti-patterns? Why, on the well-architected website, of course, at architect.salesforce.com. And actually, we're going to head over there right now. If you're not familiar to where to find our Patterns and Anti-Patterns Explorer, you can find it here on architect.salesforce.com. Let's actually head over there right now. Okay, now we're going to see a handful of filters and toggles here. But to get to the patterns and anti-patterns that we want to get to for the purposes of today's video, we're really going to want to look at our performance. So I'm going to hit performance, add a few more items. And then when we look at some of the patterns here, we see all the specific patterns, but we're going to focus right now more on the anti-patterns. Now, as you look at the anti-patterns related to throughput, if you have any sort of specific experience in the Salesforce platform, then none of these should be of particular surprise to you, right? It's a lot of like what happens when people use bad SOCL or DML in loops, or you're not using SOCL when you should. The thing to keep in mind about these anti-patterns is we're not simply looking at these from like an observable practices perspective. It's not simply oh, okay, this is what we've seen after years of experience of coding. What's incredible about these anti-patterns is that our engineering teams, meaning the people who've actually built on the platform, are noticing these throughput issues when they evaluate the code our customers are writing. In many respects, it could be the code that you're writing too. These are the common anti-patterns related to the throughput issues that many customers are seeing, right? Database queries are costly, and the bigger the data set, the longer the response time on that query, right? That's a very classic throughput issue. Let's actually look at some of those classic throughput issues inside of a Gemo. So to do that, let's actually jump into Salesforce. So welcome to Salesforce, specifically the accounts list view. And a couple of things to address up front. The first is we're going to be bouncing between two apps, right? Salesforce and Code Builder. Now, if you have never seen or heard of Code Builder yet, it's basically a web version of Visual Studio Code. We'll go back to that more soon. That's why I clicked away. We're going to focus on Salesforce for now. And the second and even more important bit is this is a technical demo, right? A lot of what was built, it was in order to show throughput anti-patterns in practice. So now we're going to code. We're going to see what works and we're going to see what doesn't. So the use case that we're looking at today is a company wants to search for an address for a specific construction site related to a specific company. So what we're going to do is we're going to click into a specific company and we're going to search construction sites. So why create a specific search capability for addresses as a demonstration of throughput? Well, it's pretty straightforward. For the first thing is we've loaded millions of these kinds of construction sites. How many million? Well, we'll find out soon, right? But more than 1 million, all right? And basically it's all address data. Second is, if you didn't know, address fields cannot be searched with global search. This also means that one of our biggest patterns that we always suggest against throughput anti-patterns, use more SOSL, can't apply, right? Because we can't index them, we can't do, custom index. Sure, I know a lot of you people are thinking out there may have done this, right? Where it's like, well, why can't you create a text field and load the text field from a flow, or create a formula field based on the address and then ask for an indexing of that from customer support? So we don't want to create more technical debt, right? We don't want to hack around what the platform does. We really want to work within the confines of it and to focus more on resolving anti-patterns, right? Because all that sounds like more technical debt. So we're going to focus more on Lightning Web Components and Apex and SOCL, which means this UI was built with Lightning Web Component, Apex, and SOCL. So the first thing you're going to see in the little UI here is this little record count, this Lightning, design system, this LDS container. And anytime we get a search, we're going to get back a response to see how much is coming in, and we'll see a spinner modal for how long it's taking. So one of the first things I'm going to do is I live in the US, the United States, and specifically a state called Illinois in it. So I'm going to search for my state. Right now, I know this is going to take a little while, not terribly long. Hopefully by the time I stop talking, it'll actually come up with a result. But it's longer than it should be. Why? Well, there we go. It's back, right? But what we're going to talk about is fixing queries to resolve throughput anti-patterns, because if it took extremely long, it's like, okay, maybe we got some significant data skew issues. Maybe there's other issues across this environment. So we're going to focus more on queries, right? But here's our result, right? It's about 8,000 records, right? Not particularly useful though, right? There's a lot going on here. I was trying to find a place, couldn't find it, don't know what's great, right? But then let's focus on a specific city. Let's focus on Port Guy. Now, one of the things I think will happen at some point is we may see a wait modal, but if we don't, we're going to keep typing. So Port Guy, and I'm going to hit Port Guy, beautiful city in Illinois. Take your family, take your friends, take your kids. I'm just kidding. It's not a real city. That's why it's a demo. It's all fake data. But Port Guy, as we can see, came back a lot quicker. Thankfully, it's about 26 records, right? Now, when we look at this data, we're like, oh, okay, hold on. We see some empty fields here. So we see it's not only bringing back exactly what we asked for, which is Port Guy, but it's also bringing back some null values that we really don't want to as well. So let's try maybe searching for a specific street, like Misty Park there. So let's see 475 Misty Park. How long that's going to take. Now, one of the assumptions, and obviously this came back pretty quick. And you may be asking yourself, it's like, all right, this is all yeah, I get it, but nothing seems to be broken, Shobi. Why are we searching this and showing this and doing all this? Now, one of the assumptions that people make about anti-patterns is that something is broken. It doesn't mean it's broken. It just means it's not as performant as it could be. The well-architected framework is all about prescriptive guidance for solution health. Think about your own health. You can walk. Maybe you could walk faster and sweat a little less with the right focus on health. Sweating a lot and breathing hard while you move doesn't make you less ambulatory. You can still move forward and build forward momentum, but you're probably not as performant as you could be as a human being. The same goes for your solutions. Now, let's take a look at the data in the back end and see how much data we're really dealing with. And that we're going to go back to our friend Code Builder. I'm going to ignore that class for now. But what we're going to do is we're actually going to jump into the SOCL Builder. So if you never used the SOCL Builder, it's a pretty great tool. If you have used the SOCL Builder in Dev Console or Workbench or other tools, it's basically the same. It's very similar. So now what it's doing is it's essentially loading from objects. So we're going to do construction site. So construction site, right? And what we want to do is we want to get a count of all of the construction sites within this environment. No filter, just a count. And we're going to run the query. So we know it's going to take a little bit of time, right? Because I mentioned it's a million, right? Does anybody care to wager how many million? Is it 2 million? Is it 5 million? Is it 10 million? I mean, starting to get up there because of how long this count is taking, right? Because remember, when you're doing select count, it's a SOCL query. It'll get a lot. Oh, here we go. We have got about a little less than 30 million records, just under. That is still a ton of data going into this single object. So that's going to be a big consideration in some of the SOCL updates we're going to make. Now, a lot of you may be thinking, okay, is this a skew issue? Maybe, maybe not. Depends on the use case. Like all things in Salesforce, it depends on the use case. In this use case, maybe we need a little less than 30 million records. Now, our app is hopefully not searching across all these records, just the records related to that account. So let's filter the count, and let's see how many records are going against that account itself. I'm going to close you out, and I'm going to modify this so that we are looking at the count again. But instead of just that, we're going to say account equals, let's grab the ID from up here, hit add. See, now we got a little filter here. Now we're going to see how long this will take. Now I'm hoping it's actually a lot quicker. So, it'd be funny if it were all 30 million associated one. Okay, good. It's not, right? So obviously that was a lot quicker, right? We're not talking about 30 million. We're talking about 420,000 just about, right? And as we saw in the state query, we can get even lower, right? When I searched for Illinois, it was about 8,000 records. When I searched for a city, it was about just a handful of records. So all these ranges are still pretty reasonable, right? In the context of a query that we're working on, SOCL that we're working on, and evaluating its throughput. Nothing's broken, right? We're not seeing anything broken quite yet, but we can look to make improvements to the app and make it more performant. So let's walk through the app by opening the Lightning Web component and the Apex class. So I'm going to close out Friends here. So if you're not familiar with LWC, here in Code Builder, we've got LWC, and the name of our thing is Throughput Demo Data Grid Problem. Did not say I was going for original naming. But here, we can see a Lightning Web component. Now, as you can see, there's a lot of code in here. Now, you've been wondering, okay, Shelby, there's a lot going on in here. What matters to me? Here's what matters to you. When we look at this input here, when we typed and we hit enter, this is that input. Essentially on handle key up, meaning on enter, it's basically searching across the entire organization. And then what it's doing is it's bringing the result back in grid columns. So where's this going? Where's that little handle key up going? Well, that is going to our JavaScript file. Now, once again, our JavaScript file has a lot going on, but really matters is the handle key up event. And what it's doing is it's taking that value and it's querying this query term, and it's taking this query term and it's passing it to this Apex class, get construction site list, and it's passing two values, not just the query term, but the account ID as well. At least in the context of this, we're passing in the account ID so it can filter it that way. So let's actually take a look at our Apex class now. All right. Now, this is probably where we're going to spend most of our time, right? Now, remember that this Apex class and method is technically just literally one line of code. There's not much going on here. For the sake of our throughput issues, there's actually quite a bit happening here, right? There's a lot going on in the query itself, and a lot of places we can actually see some of the anti-patterns that we're already talking about, right? Let's flip back over to the Explorer, and remember, let's remind ourselves really quickly, okay, what was there, right? We saw a lot around, let's take, for example, all keywords are being used in the statement, right? All rows, there we go. That's not good. We're not using nots. We're using a lot of likes. Here, we're actually using quite a few likes, almost every single like, right? And there's also a significant lack of not null, right? We're not filtering that at all. And as we saw some empty streets. So as we see, we've got a lot of different kinds of elements of query here. And one of these may not even be all that useful as I think about it, right? So like street address. Now, I don't know about you as a person, right? But when I search for street address, I'm not typically saying, oh, I need, if I'm on Google, if someone tells me, oh, I'm on this street, if they tell you the address, 475 Misty Park, that's your address. But if they're like, oh, I'm on Misty Park, like, okay, Misty Park, I'm in the city, I know what city it is, I know what all this is. But now we get a result back, a null result, right? So this is not exactly functioning the way we want, right? We're not seeing significant throughput issues, but we're seeing enough where it's not performant. And as we can see on some of this, it's actually, we could probably improve the performance, improve the capability, and improve the throughput. So what we're going to do is we're going to give this a little bit of an overhaul. Now, we're going to try to do it as quickly as possible, but bear with me while I make updates to our SOCL query here and make it work a little bit better for all of us. All right, here we go. Because I didn't want everyone to watch me just type manually a SOCL query, I just copied and pasted over what we'll call better SOCL that addresses some anti-patterns into this Apex class instead, right? And we did a couple of things here, right? The first thing is removed a lot of the extraneous declarations. Now, I commented out the old SOCL query down here. It's still down here just for reference, right? But we had a lot of stuff like lat long and geocode, didn't need it, so popped it out, right? Second is we had a ton of likes, as we saw, a lot of likes. So remove majority of the likes, went more for less like relative searches and more for exact matches, right? On city, state, and postal code. We did keep a relative one, though, on the query term address, right? Because one of the things that we did, like in our testing, was to see if like that search would actually bring back a partial street name. It did not, right? So that's why we added a little bit of wildcard capability to it. We kept a like, because for our specific use case, we actually do need a like, right? So we're accommodating that. Now, a lot of you keen observers may be observing, it's like, okay, you've got a not equal to null, and we just saw an anti-pattern where you should not have it, and that's true if it's your only method of selection, right? If it's your only method of filtering. We have multiple methods of filtering on this query. So adding that null check just makes it a little bit more performant, right? Finally, we got rid of that all rows keys, right? For those of you who don't know what all rows does, what it actually does is that it searches is deleted and is archived records as well. We don't need that in our use case, right? It's just searching like more than it should. If you have use cases required, keep it. In our case, doesn't. It's just adding extra burden to the search, and we want to remove that to gain some throughput efficiencies. Instead, we added for view. While for view doesn't necessarily give us anything great, right? It's a great best practice in order to assure that when the user is looking at the records, that it updates that last viewed date, right? Because it's being viewed in the context of a search. All right. So let's see if it actually got any faster. So what we're going to do is I copied it, but I'm going to deploy it too, right? That's one of the great things about Visual Studio Code. If you have a chance to utilize Visual Studio Code or Code Builder, which they're basically the same app, sometimes I call them one or the other, right? You can essentially do all of your deploys the same way you would do in VSC, the same way you do in Code Builder. All right, here we go. Deployed. Let's go back to our app. Let's hit refresh, and let's actually try one thing first. All right, let's try that Misty Run search first. All right, so Misty Run, I'm going to hit enter, and let's see if we get back a result. Last time we got back no results. Now we got back 2 results, right, where Misty Run is showing up here, right? That's great, right? It's better than 0. Right, now let's look for Port Guy. Now, last time when we searched Port Guy, we had, I believe, about 26, right, but with a lot of nulls. Now I got 19, right? It actually came back a little faster this time. But, but the great thing about it is that like we did, a little bit of work and we got back a great result, right? So if that makes sense, in the context of what you're doing, like these are appropriate ones. But like, I'm going to throw a little bit of a curveball here, right? Because one of the things that we also did was we added the wildcard ability, right? It's helpful in Port Guy. It's helpful in all these. But what if I search Illinois again, right? Because now it's not only searching against that 8,000 records, it's also searching against some of those address names as well. And I don't know about you, but there's probably quite a few addresses that have the letters I and L in them, right? And so is this going to run any faster? Not particularly. Remember, these address fields are not standard indexed. They're not custom indexed, Plus now we've added that issue around the query term where it's adding the wildcard. So now this is going to take a little longer, if not crash on us altogether, right? So this is where we resolved some particular and certain throughput anti-patterns, but maybe we didn't completely resolve all of our anti-patterns related to everything related to performance, right? Now you may be wondering, like, what are we talking about in that instance, right? Now look at this, right? Now we've added 24,000 records, so that's a lot. And probably because I and L across all of them, right? We got it back. Artificially, it didn't crash, which is great, right? Especially for throughput. But there we go, page unresponsive. So this is often what it means when you're trying to resolve anti-patterns and patterns, right? Especially around performance, because while we resolved a handful of them, we made another search throughput. So that's where we have to look at other anti-patterns to see. Like, all right, so we're going to head back to the anti-pattern explorer, and we're going to say, all right, what else is in performance? All right, you got performance here, you got availability, scalability, performance. It's not just throughput, it's also latency. We saw a tremendous amount of latency issues. Now, one of the things that we talked about is, well, why not just put, this in a formula field and search it that way? May not make it faster. Formula fields are not indexed unless you get them indexed custom. But then, of course, if your filter contains formula fields, not great, right? Are we we utilizing a lot of our LWC, in the context of Apex data operations? Yes, we are, right? So doing a lot of that within this query itself, we're creating some of this. So what we've done in the context of this application, which is now wiped out, is by resolving a couple of anti-patterns, we've actually potentially created some more anti-patterns. And that is where it's important to make some of those design decisions. Because the key thing to keep in mind about Salesforce, that's why there's so many of these patterns and anti-patterns, is that no solution exists within an ether, right? This web component could be placed anywhere in the context of the solution, right? It could search any kind of data. So is it, utilizing all the different methods of patterns and anti-patterns across these different dimensions, right? And for the sake of throughput and the sake of performance, we resolved as many as we could. But then we got some latency anti-patterns as well. So that is really what it takes. Now, at some point you may be asking like, all right, do I really just need to wait for the app to crash before I can really test whether or not it's working? No, there's actually some fantastic tools, which we'll actually look at right now. Okay, so at this stage, we obviously saw our app crash. Now you'll be wondering, an app crashing is not the best way to test. But there are a specific tool that I like. Now, you can utilize other tools like developer logs instead of the developer console and, just good old-fashioned timing. But one that I am a big fan of is Scale Center, right? Now, Scale Center, I have activated in this demo. And the reason I want to show it is that while we're only debugging one single Lightning Web component, right? What I like about this is that the activity that we were literally doing in that component, we were searching and queries, it's actually reflecting within Scale Center almost immediately. So for measuring throughput, I really wanted to show three specific kinds of graphs, right? Average request time, total CPU time, and total request volume, right? Now, when we look at these, it's pretty interesting. So the average request time, we can kind of see, kind of long, right? We're making some of those queries, we're making some of those updates. And what I really want to focus on these two, total request time and total CPU time. Now, a lot of these may be wondering, wait a minute, are these like reflective of what? Like, what are we doing? Well, remember, we made searches, right? We were making searches inside of our app, right? We were doing a little bit of a demo and we were making query searches. And then I'm guessing around the time that I searched Illinois, right, that first time, all of a sudden I see a staggering jump in the requests, right? And it's not just a single jump. It's also, the API jump as well, because it's reflective of query. And what's even more important here is that on the total CPU time, we got two here. We've got app CPU and DB CPU. Now, remember, we're making Salesforce is a highly coupled platform, right? When we make that app request, that, hey, send out this query and bring back this data, it's making a significant outcome and expectation of that data, right? So it's not just the database doing work, it's also the app doing work, waiting for the data to come back, processing the data that's come back, displaying it on the view for the user, all that, right? And as we can see, while we may have done a little bit more of an improvement, we could probably still do a little bit better, right? And what I love about these graphs specifically is that they do give a pretty nice measure of what your overall throughput looks like. Now, let's just say that, in this situation, like, all right, it's just myself as a developer working on one Lightning component inside this environment. Now, the real power of Scale Center is what if I added 100 more developers or 1,000 more with 10,000 users and maybe a bunch more architects like myself? Then I can start to really analyze and see all the throughput issues across the entire environment, because any application, any solution you build on the Salesforce platform doesn't exist on its own. It's going to be hyper-dependent and hyper-coupled, right, against everything else that's happening. That's why that UI request, that's coming up here, that's why it's so high, right? Because the UI is coupled to the rest of the app layer and rest of the DB layer, right? And understanding this impact, understanding the changes that your solution is making to the holistic view of your entire environment is really important, right? Because this is what you need to maintain health inside of your organization. And this is how you keep your solutions well architected. I wanted to thank everyone for joining me today as we talked about throughput patterns and anti-patterns, and overall anti-patterns in the scope of performance. You can find more of those patterns and anti-patterns as we showed on the well-architected website today. Also, you can find this video along with other videos on our LinkedIn feed, our YouTube channel, and find more blogs coming all the time on architect.salesforce.com/blog and on our Medium site, medium.com/salesforce-architects. So that's it. I want to thank everyone for watching this video and have a wonderful rest of your day.